we are live at, yes, we are live right now. Okay, so Nikhil, do you want to explain the question here?
Right, question explanation ये काम तो मैं बहुत अच्छे से करता हूँ.
Okay.
So the question is, we have a node. The distance between a node and a binary tree and tree's root called the node depth. Okay, the function that takes binary tree. So we have a binary tree. Binary tree is a tree which has two nodes, like two child nodes, right, Anmol?
Okay. Yeah. Every
I'm asking the
binary tree.
question. Has
Okay.
two nodes,
Okay. Okay.
two
I'll
child
explain the
nodes.
question.
Okay.
I'll explain the question. So this is a question of node depth, in that we have to find the depth of any nodes. So in this question, they have given a binary tree. Binary tree is a tree which have a left and a right node. It doesn't mean they have to be equal, but it can be a left node and it can be a right node. So
So the maximum is 2 and minimum is 0.
yeah, maximum is 2, minimum is 0. It can have left node. It doesn't need to be have to doesn't need to be a right node as well. So if we have to do this question, so if we have to find the depth of any node, then we have to iterate from top to bottom. There is no way for any of us to find if we have the third position and we know that this is the third position of that node, without even checking that from the top that it is at a third. So for this question, we have to always iterate from top to bottom. We cannot do from bottom to top. We will use recursion here, so it will help us to solve this question very fast, and it will
Mm-hmm.
be a better approach. So if you can
So
see
my
this tree.
question is,
Okay.
we can have multiple depth at different levels. Like considering the top, like root node,
Mm-hmm.
we can have multiple depth
Okay.
at any stage, at any instance. So we have to find the maximum one, or we
Yeah,
have to sum
we have to find a depth.
all those
So
depths.
the depth of any tree is considered as the maximum depth. So for this tree, 1, 2, 3. So 1, 2, 2 to 4, 4 to 8. It has depth 3,
Mm-hmm.
0, 1, 2. 0, 1, 2,
Mm-hmm.
3. So the maximum depth will also always consider, and we have to return that depth value.
Cool.
So okay, so I'll start this question by, like, without any further ado. So what I'll do, I'll make another function. I'll return a function. What will it? And it will be a recursion function, in that we will be writing the logic. So something like this, and I'm returning a function which is node depth sum. In that sum, we have to pass some values. Okay, we'll figure out later what are these values. First, just make
Maybe
a function.
the node and the total.
So we obviously we have to pass a root value. We have to pass a
Yeah.
root because we have to pass our tree to our recursion
Mm-hmm.
method, and we have to pass at the first depth. So at one position, the depth is 0. So we have to pass a single depth as well.
Right.
So at 0, so it can start from 0 to the next value. And if I have to write a function for this, what it'll take a root, and it has a 0, and then
Yeah.
what we check if our
Then we
root
can
is,
start writing the function.
yeah, we can just start writing a function directly. If root is none, then we can directly return 0, that we are at the end of that node, and the sum we are returning is 0. Nikhil, can you stop uh, scrolling that cursor? Okay,
I'm not on your
then
screen.
you're not my screen. Okay, so what I'll do, I'll use that function, and I'll
Mm-hmm.
change the root node to its left. So what we'll do, we'll iterate it to the left once, and then right, then left once and right. So how we'll do it? We'll do
Yep,
root
that makes
dot
sense.
left, and okay.
So we may need to increase the sum before we go inside it, or we
Yeah,
will do it later on.
no, we have to increase the sum whenever we call this recursion method.
Hmm. Oh, maybe we need to create that variable name
So
here.
we
So
have to pass the depth here.
yeah.
Hello, Nikhil.
I'm there.
Okay. So if I try to do this, I'm passing a depth which is 0. If it is at the end position, we are returning nothing. We are returning that this node has only zeroth uh, depth. Okay,
So that's what, yes.
and if we have
If you proceed further.
proceed further, then we'll check on the left node, and the depth is 0. It will pass 1 first. If it is go again, it will pass 2, and it will like it will be a recursion method. And for this, just do the same for the right part. So if I run this code,
Yeah,
I'm
and
pretty
we keep
sure.
on adding.
Oh,
Right. All work.
on the first attempt we have solved this question. That's nice. And yeah,
All credit goes to you.
this is very simple question, and we just have to find the binary trees depth, node depth, and
Just by recursion. Just
just
like
by recursion.
trying to find the basic,
So
you
if you
can say the
think about
solutions
this
that can be
question,
iterated over again and again. Yeah.
yeah, if you think about this question without recursion, you have to like scratch your heads and you have to think a lot of things. But with recursion, we can do this in just 3 lines. So the
So if you
complexity of
use recursion, yeah,
so the optimal
go ahead and move.
complexity they have given is big of n and spaces n as well. So here our complexity as well is big of n. So we have reached the optimal complexity, space complexity or time complexity. Yeah,
Yep.
this would be time complexity. And yes, that's all. If I submit this code, it'll pass all the checks.
Good. Easy solution
Easy solution, yeah. So we'll come back again with another AlgoEpert problem.
and
Till
an
then,
easy solution.
and easy solution, yes. An easy problem with easy
Yeah.
solution. Okay, thank
Okay.
you.
Yep. Bye bye.